Okay, this is a data passage. We know it's a data passage because we only see the charts, the graphs. We don't see study one or study two, or scientist one versus scientist two, so just data. So in our DRC approach, D means data, and that means don't read, just spend a small amount of time quickly orienting yourself to the passage. And then when you go through the questions, use the R and R approach, the read, then reread. So you do the read, and then as we're going through it, we're rereading. So hopefully this is the second time you've looked at the question. So a quick orientation, there's a ball that's being released and it's sliding down the path, and it's going to have a trajectory as it comes off the edge. We have a sphere that rolls and a sphere that slides. That's all we really need to know about this passage before we go to the questions. Number 12, based on figures 2 and 3, so we're using both those for this sphere that's either sliding or rolling. It's an important part of this particular passage. One of them was a sliding sphere and one of them was a rolling sphere. And for an h of 1.5, so we're using the x in the rolling sphere and the square in the sliding sphere. And as theta increases from 5 to 45, x does what? So it's going to be the same in both. It increases and then decreases. So your answer is H. Number 13 for the sliding sphere. So the sliding sphere is figure 3 at a theta of 10 degrees. So 10 degrees is right there. We can go all the way up with it. If H is 0.5, so we're having to add something in. So 0.5 will be less than 1. So you can see the symbols progressing. X would most likely be, so it's going to be below the triangle, so here, which is going to be less than 0.56, so A. Number 14, for the sphere sliding down, so we're using figure 3, the sliding sphere, and an H of 2, so it's the star. If X had been plotted every 2.5 degrees instead of every 5, so we were plotting it every 5, right? So we're doing it 2.5. We're shrinking the measurement. Where would it have been the greatest? So we're going to plot that, and we see that it peaks right about 27.5. If you didn't see that from drawing it, right, because these 2 points are the same, which means it went up a little more and then went back down in level with each other. You could just check the answers as well, draw your line up and see 17.5 is definitely too small, 22.5 small, and 32.5 too small. So your answer has to be H. Number 15, we're looking at the rolling sphere, so that's figure 2. And we're looking at an H of 2.0, so that's the circle. We're looking at a theta of 50, but 50 is not on the chart, so we have to add that in. We want to know what will X be closest to. So if we follow the trajectory of the circle, continues decreasing, then we'll end up being closest to 0.65. B. Number 16, which of the following figures best shows how the sphere's kinetic energy varies with time as the sphere travels down the incline. So we have a little bit of knowledge. We have to know that kinetic energy is the energy an object has when it's moving. So when the sphere is at point A, it is still. It is released from point A. It is not moving. So if it is not moving, it has no kinetic energy, and the only choice that starts at 0 is choice F. So to quickly review our answers, number 12 is H, number 13 is A, 14 is H, 15 is B, and 16 is F.